A stem plot is constructed by dividing each value into the high order and low order digit. Each row of the stem plot represents the high order digit of the values, while the low order digit will fill the row that corresponds to its high order digit. Let's now generate some data. Note, the first digit is a 66, which means that the row labeled with a 6 for the high order digit will receive a 6 for the low order digit of the value 66. The next value is 98, so the last row labeled 9 for the high order digit receives an 8 for the low order digit. The next value of 77 results in a 7 being placed in the row labeled 7. Each of the values in the dataset is split the same way. That is, the low order digit is placed in the row that corresponds to its high order digit. When all the values have been through the same process, the stem plot is complete. It is often required to have the leaves arranged in ascending order. It should be noted that the rows in the stem plot are similar to the bars of the histogram, and the original data can be retrieved from the stem plot. Another method to represent data on a chart is the dot plot. The horizontal axis represents the value of the data, and the vertical axis represents the number of times the data values occur. Let's now generate some data. The first 8 results in a dot above the 8. The first 9 results in the first dot above the 9. The first 5 results in the first dot above the 5. The first occurrence of a number results in a dot placed in the first row above the number value. Notice when the second 8 occurs, it results in a second dot above the 8 in the dot plot, and the second 3 results in a second dot above the 3 in the chart. Each value in the dataset is represented by a dot in the dot plot. This procedure is continued until all the numbers in the dataset are placed in the dot plot. The height of any given column is the number of times the value occurred. For example, the value 0 occurs 6 times in the dataset, and the value 8 occurs 12 times. A third method of representing a set of data is that of a time series plot. The horizontal axis represents a unit of time. It could measure days, weeks, or months, or hours, minutes, or seconds, depending on the application. The vertical axis represents the value of the data. Now let's generate some data. The data is then plotted on the chart in the order in which it occurred. The value of 7 occurs first, and is therefore plotted first. The value of 6 occurs second, and is therefore plotted second. The value of 8 occurs third, and is therefore plotted third. So each data value is plotted on the vertical axis, and the horizontal axis indicates when the data occurred. We continue this procedure until all the data is displayed on the time series plot. A box and whiskers plot gets its name from its appearance, which will be clear once we have drawn the chart. In order to draw the box and whiskers plot, we must understand the idea of quartiles. The first quartile is that number in the dataset which is greater than 25% of the data values and less than 75% of the data values. That is, x is greater than 25% and less than 75%. The second quartile is that number that has 50% of the data values less than its value and 50% of the values greater than its value. That is, x is greater than 50% and less than 50%. This is also the definition of the median. The third quartile is that number which has a value greater than 75% of the data values and less than 25% of the data values in the data set. That is, x is greater than 75% and less than 25%. Let's now get some data. In order to make use of the quartiles, the data must be placed in ascending order. Once the data is in ascending order, the values needed are easily found. The minimum value, 5, is positioned in the chart above the value 5. The maximum value, 39, is positioned in the chart above the value 39. These two values indicate the range of the data set. Recall that the second quartile, or the median, is that number where 50% of the values in the dataset are less than its value, and 50% of the data values are more than its value. When 100 data values are arranged in ascending order, the median, or second quartile, will be between the 50th and the 51st position. Since there's no data value between the 50th and the 51st position, we take the mean of the two for a result of 19.5. We then represent the median on the chart with a vertical line above the value 19.5. Now recall, the first quartile is that number where 25% of the value is less than its value and 75% of the value is greater than its value. We can also think of it as the median of the first 50 numbers of our data set, which falls between the 25th and the 26th position in the data arranged in ascending order. Since there is no number between 25th and the 26th position, we take the mean of these two numbers, which is 14. The value of the first quartile locates the left side of our box, which is above the value of 14. Finally, recall the third quartile is that number where 75% of the data values are less than its value and 25% of the values are greater than its value, and can be thought of as the median of the second half of the data set of 100 values. The third quartile falls between the 75th and the 76th position when arranged in ascending order, and is the mean of the two values in those positions, which is 30. The value of the third quartile locates the right side of the box, which is above the value 30. In summary, there are 5 values necessary to draw the box and whiskers plot. The minimum value, which locates the left whisker. The second value required is the first quartile. In our example, it is the mean of the two numbers in the 25th and 26th positions, which is 14 and locates the left side of the box. The third number required is the second quartile, or median of the data set, and is the mean of the values in the 50th and the 51st positions when arranged in ascending order. Its value is 19.5 and locates the line within the box. The fourth value required is the third quartile, and for our set of 100 values is the mean of the values in the 75th and the 76th position, and its value is 30 and locates the right side of the box. Finally, the fifth value required is the maximum value, 39, for our data set, and located the right whisker.